What's up, AP Stats? Continuing with Chapter 10, page 4 and 5, dealing with simulations and understanding randomness. So in this game, or in this problem here, we're going to be talking about the game of 21, which we can play with a 6-sided die. And the point is that you and the person you're competing with tries to get to the number 21 by rolling a die, and you want to get as close to 21 as possible. So competitors each roll a die repeatedly, trying to get the highest total less than or equal to 21. So for example, if I rolled a 4, then a 6, then a 5, then a 6, I would be at 21. If my competitor rolled not a 7, you can't roll a 7. If you roll a 5, let's say you rolled a 5, 5, 2, so he's at 12. 6, he's at 18. And let's say he wanted to roll again, but maybe he rolled a 4 here. Well, what would happen? Well, he actually... Oops, what did I just do? There we go. So if he rolled a 4, now he's over 21. He is at 12, 18. He's at 24. No, 22. And that's not good. You cannot get over 21. You have to get as close to 21 as possible without passing 21. So that first guy would win there. All right, so that's a game of 21. Sometimes that can be played with cards as well. It's a different name. So if your total exceeds 21, you lose. So let's say our opponent rolled first and he rolled an 18. So we want to beat him. We want to beat him by getting more than 18 without going over 21. So basically, we can roll a 19 and win. We can roll a 20 and win. We can roll a 21 and win. But anything more than 21, we lose. And anything less than 19, we don't win. So we want to roll 19, 20, or 21. How many rolls do you expect to make, and what are your chances of winning? Okay, so a couple different questions here. So we're gonna set up a simulation that models the scenario. That way we don't actually have to roll the die a bunch of times to figure out this question. So the component here is we're going to use the numbers 0 through 9. And we're specifically using 0 through 9 because in this question I'm going to show you how to use a random number table. And if you look at the random number table, I told you that this is most likely how you would see this on an AP test. And yeah, these contain the digits 0 through 9. And I know that in this case we have a 6-sided die, so we're not actually going to use every single one of those. So we're going to use the numbers 0 through 9. We're going to let 1 through 6 represent 1 through 6 on the die. And we're going to ignore 7, 8, 9, and 0. So we're using the numbers 0 through 9, and but really we only want the numbers 1, 2, 3, 4, 5, and 6. So whenever we see a number 7, 8, or 9, or 0, we're just going to ignore them. And the numbers 1 through 6 will represent a roll on a die. I kind of already answered B, so. Okay, number 2, trials. How will you combine components to model a trial? So a trial will consist of keep selecting components until the sum is at least 19, right? We want 19. And then from there we can look at what happened. All right, we want to get at least 19, and then one of two things can happen. All right, so with the response variable, what's going to happen? Well, either we get 19, 20, 21, in which case we would win, or If we get past 21, if we get 22, 23, and so on, we would lose. So the response variable, there's actually a couple different things that's happening here. The first thing is that the number of rolls to get a sum of at least 19. All right, we're trying to see how many rolls do we expect to make. And that was in the original question. The original question said how many rolls do you expect to make and what are your chances of winning. So we had two questions. The first one was like how many rolls. So in this case, we're going to be looking at all the wins and seeing how many rolls there were. Number two, what was our percent chance of winning? And remember that for this, we have a loss if we go over 21, and we have a win if we get 19, 20, or 21. Okay, so we're going to model the situation. We're going to look at a random number table, and we're going to look at the numbers 1 through 6. We're going to ignore 7, 8, 9, and 0, and we're going to play this little game here. We'll say for 8 trials. We'll do 8 trials, and we'll see what happens there. And the reason I selected 8 was because I already looked at my random number table. Like, there's 8 rows here. So like this first row is 1 trial, second row is my second trial, third, and so on. All right, so here's what I'm gonna do. I'm gonna copy down these numbers and put them in the last page of the notes, page 5. So for the first trial, let's write down 61424. 61424. So I'm looking at these. Let me write down a few more numbers just in case. So 20419. And we probably won't need all these. That's okay. We're using that first row for our first trial. So starting with our first roll, we got a 6. Okay, so our total's at 6 right now. Then we rolled a 1, so now we're at 7. Then we rolled a 4. We are at, quick math, 11 plus 2, 13, plus 4. Now we're at 17, right there. Then we rolled a 2. Now here we are at 19. And remember, the whole point of this game is we wanted to get over 18 and then see what happens. So in this case, we rolled a 19. So we rolled a total of 19. For this first column, let's actually do the number of rolls. Remember, we wanted to see what the number of rolls were. And in this case, it took us 1, 2, 3, 4, 5, 6 rolls. 6 rolls to get there. And did we win or lose? Well, we rolled a 19, so we won. Cool. All right, and then what I'm just going to keep doing is I'm just going to run this simulation 7 more times. So I do want you guys to see at least one more simulation. And then, honestly, if you guys could, go ahead and like pause the screen and try doing this yourself and see if you can practice running the simulation using the random number table. So I'm just going to do the next one, and then from there I'm going to fast forward. All right, so this next one we have 90222. 222. Okay, I know we're at 15 there, so I got to keep going. So 27993. We probably won't use all those. So I'll stop at 7. All right, so 27993. Okay, so important thing. I almost messed up here. Remember that we're only using the digits 1 through 6. So you cannot use the 9 or the 0. So in this case, our first roll actually is a 2. Second roll is a 2. Third roll is a 2. So now we're at 6. Fourth roll is a 2. We're at 8 right here. Can't use 7, can't use 9, can't use 9. Remember, we're only using the digits 1 through 6 because they represent the die. So I actually have to add more digits here. 0, 4, 9, 5, 2. Alright, let's see what we got. So we're at 8 after the fourth roll. We're at 11 here. 0 we can't use. We're at 15 here. Can't use 9. And at 5 here, we actually hit 20. We don't even need this 2. So what does this mean? How many rolls did we take? 1, 2, 3, 4, 5, 6. Took us 7 rolls to get to 20. And since we got to 20, we didn't pass 21. Here is a W. Okay, so at this step, guys, I'm going to pause my recording, and what you guys should do is continue these trials, and when I resume my recording, I'll have this all filled out, and we can come back and answer number 4. But I want you guys to try 3 through 8. Alright guys, hopefully your simulations match mine since we were using the same random number table. And again, for the random number table, we said that we were going to use each row to represent a simulation. Now one thing to notice is that for I think these last 4, we actually had to go into the row a lot farther because these numbers like look at this one right here, 8990, none of those are usable, right? We only wanted the numbers 1 through 6. So depending on the random number table, you may have had to go further into the row of digits. Remember, we wanted to stop as soon as we passed the number 21. So what I have here is that we lost the majority of the time. Really, the only time that we won after those first 2 should have been the last one, the last trial. So we only run 3 out of 8 trials. Okay, so we can say that the average rolls was, if I take these numbers, add them all up, divide by 8, because there was 8 trials, so it's 53 divided by 8, we actually have 6.625. So the average, the expected amount of rolls that we're going to make is about 6.6. The second question we had was, what are our chances of winning? So now let's answer the second question. According to our simulation, how many times did we win? What were the chances or the odds? Well, we only won 3 out of 8 times. So chances of winning are, 3 out of 8. And with chances, we like to get percents, like the word chance, we'd like percentages attached to that. So 3 out of 8 is about 0.375, which is about 37.5%. So our chances of winning aren't looking too good, considering that our friend already rolled an 18. Alright, so last step here, let's state our conclusion. And for a conclusion, it's pretty much just summarizing this, but remember that we need to mention that we are running a simulation. So if I answer the first question about what was our expected numbers of rolls, we would say, based on our simulation, we expect to roll about 6.625 times to get a sum larger than 18. All right. Very important that you have based on our simulation. That is something that the AP will take off when it comes to the exam. And the second question, based on our simulation, our chances of winning are 37.5%.